Well, hello, this is Philip Schump with the 1015 podcast. We're going to talk a little bit about history, and that somehow seems appropriate. It's September 11th, and interestingly enough, I'm actually standing outside in the rain recording this. I don't know if you can hear the rain, but I'm getting dripped on while I record this. And the reason I'm out in the rain is I have a friend, his daughter came here to university this year. It's kind of a strange time to come and be a freshman at university, but today is her birthday, and I took her a present because, it's kind of a sad time. I mean, and, I think her birthday is kind of emotional. It's certainly emotional for me. So, let me tell you some things about the day she was born. I was in my living room, and my CEO called me as I was frantically trying to get out the door. My kids were bugging me about something, and he said, "You got to turn on the TV. You got to turn on the TV." And I said, "What's up, Matt?" And he said, "Just turn on the TV." And I turned on the television, and just in time to see the plane fly into the second of the Twin Towers. And some people have these nice, calm relationships. Our relationship as CEO and CTO of that company that we'd founded was always one where we tended to argue. We'd argue, then we'd resolve things, and we'd move on with a decision. And this was one of those arguments, and this time it was over the phone, and it was about fundraising, as I proceeded to tell him that, what I'm seeing tells me that we are just dried up all of our fundraising right there. And he said, no. We've got a letter of intent for $5 million in cash. Okay, they're going to come through. They'll fly out this Friday. Okay, I think it was Wednesday, and they were going to fly out like 3 days later. And I said, no way, we're never going to get the money. We never got the money. We survived, yes, through this. We had to do some ugly things before it was done, like there's a person we'd told, since we had a letter of intent, that we'd hire them. We had to tell that person, no, we are not going to hire you because, yes, we don't have any money, and that wasn't very pleasant. I'm surprised, to tell you the truth, that they didn't sue us over that one, but they didn't. And we had two competitors in our little corner of the world, and what we were doing with Oracle databases, one had raised $10 million and the other 39. And within 6 months, the 9/11 and the Twin Towers had put both of them out of business. And we survived just barely. It was a long, hard haul. But as I was watching this happen, I was thinking to myself, I've stood on top of the Twin Towers and looked down, and you could see like an advertisement painted on top of a McDonald's on the roof. We deliver to the Twin Towers, McDonald's. And I was also thinking, I have a friend, Chip, that works in the Twin Towers. And finally, I'm going, what is going on here? But, there were no answers that day. They did shut down all airline travel. No, the people did not fly out from California with our $5 million. And it would be quite a few days before I found out that, yes, my friend Chip he lived in New Jersey and he commuted into the city. He had been a couple minutes late for his train. He worked on floor 82 with an investment management company, and he had missed his train. The train had gone out underneath the Hudson River and stopped. The conductor for the train had told them that they were stopped and that for various reasons he had to turn off the lights inside the train to conserve power, but they were stopped and there was no problem with the train. They just received an order to stop and stay in place, and no other trains were moving. For some reason, he didn't know what was going on. Meanwhile, his wife was in her 9th month of pregnancy, and they had figured that even if she went into labor, that he could, leave work real quick, catch a train back. It was only about a half an hour from where he lived into the city, and he would be there to help her. She went into labor, and yes, the train stayed underneath the Hudson for 4.5 hours, basically in the dark. There were the emergency lights for exit, but the train wasn't moving. And that's where Chip was for 4.5 hours, not knowing what was going on, basically in the dark with a bunch of strangers, while his wife delivered, and everybody else on that floor, everybody else in the entire business was killed. He was the sole survivor of an entire business. It took its economic impact on him. Basically, the business went away. He lost his job. It ended up causing them to lose their house. That's part of the reason why his daughter came out here to go to school, because it's much less expensive than going to school at somewhere like Connie City, University of New York, or New Jersey State, or some schools out there. But it had an impact on him. But he was really lucky because he missed the train by 2 minutes. And if he had been on that train, he would have been in the building when the plane hit. So that's kind of a sobering thought, but we are talking about history today, and that is part of the history, that I've been through. I was going to talk about Unix and the file system, and besides standing here getting dripped on, let's talk about Unix and the file system. I think that's a little bit happier history. But in 1969, and this is not the beginning of computers. This is people are building computers and they are around and they're working on things. We're probably going to get a podcast where we go back farther to a lot of the origin of computers and functional programming and lambda calculus, and have a podcast that goes way back to the beginning of computers and talk about some of the amazing things that were invented. Like we're showing in class, subroutine calls. That requires a stack. One person in a single year invented floating point numbers for computers, the first floating point library, and stacks. One person in a single year. So some years had passed since, Bentley Park in 1937, and this is 1969. And Bell Labs, one of the foremost research labs in the United States, had a joint project with IBM, and the project got canceled. And a guy by the name of Ken Thompson and Dennis Ritchie were on that project, and they went back to Bell Labs, and they were not happy with this because they couldn't play their game, Space War, because they didn't have an operating system. And they decided that they had this PDP-7 computer with 4K of memory, and that they could build an operating system so that they could play their game. So they built an operating system to play a game. And they named that Unix. I'm not certain what it stood for. It wasn't spelled the way it is today. But yes, they built it, and they started adapting to this very minimal architecture. And I have a quote from Dennis Ritchie and Ken Thompson in 1972 at a presentation. And they had built up this system for a number of people. And the quote is, "The number of Unix installations has grown to 10, with more expected in the future." And, we are in that future. And what do we have for Unix installations today? I'm a Microsoft shareholder, so, you get the annual report, and the last annual report, they said that they had over 400 million installations of Windows 10. And that sounds like a bunch. Some of you in this class are using Windows. There's some good things and some bad things about it, but it's a stable operating system today. By and large, it's really, really useful. And I have machines in my house that run Windows. Most of the University of Wyoming campus runs on Windows. But I also have these other systems, like a Macintosh and an Android phone, an iPhone. I have Linux systems that we do research on. Linux systems that I use for file servers and database servers and things like that. So I do use other operating systems. Now, Linux was built as an open source clone of Unix. and is considered to be a Unix compatible system today by the Unix Foundation and what they look at. The people say that, yeah, it is a Unix system. The Macintosh is sitting on top of a version of OpenBSD 4.2 that evolved into their Darwin system, and OpenBSD is an open version of Unix. There are other Unix systems. Your Android phones are sitting on top of a Linux operating system. iOS on iPhones and iPads is a Unix operating system. It's also based on the same Darwin core that runs on Macintoshes. So if you ask the question of how many computers there are out in the world to Google, it's going to tell you somewhere around 2 billion, and it's counting all the phones and Macs and a bunch of other stuff. But other than the 400 million Windows systems, they're really looking at, the desktop and handheld computers. And most of them, well, other than 400 million, most of them are running some form of Unix. And that's a little bit larger than 10 and more expected. But it turns out that if you dig a little bit deeper, you ask how many IoT devices there are. And IoT devices, my thermostat, my fridge, good heavens, they make toasters that have computers in them today. I don't have one of those, nor am I going to get one of those anytime soon. I do not need a computer in my toaster, but my thermostat on my wall, there are a lot of these devices. Computer routers, all sorts of things. Controllers for sprinkler systems, and big controllers for sprinkler systems on ranches, and the computers inside your car. These are all IoT devices. You'll see that they think there are around 7 billion of them. The world population is about 8 billion, so there's almost one for every person in the world today. And that number is growing quite rapidly. They expect in 15 years that there will be around 50 billion IoT devices. And what operating system do they run? Well, there are really 3 that are common. One of them is running Linux. That's about 20%. Another one is called VxWorks. And some things run a real-time operating system that has nothing to do with Windows or anything else called VxWorks. Chances are your car may run it, although Teslas are running Linux. So some cars are not, but there are cars that are out there running this VxWorks system. And it turns out to be about 13%, and some other esoteric operating systems you've never heard, like Symbian OS. And some of these IoT devices don't have an operating system at all. You can build an IoT device without an operating system. But all of those other things count for 13%. Now, the gap in between the 20 and the 13 is dominated by a thing called RTOS, which is a real-time version of Linux. So most of these systems out here, most IoT devices are running Linux or real-time Linux, and the difference is how it schedules things when it runs. So there are literally 5-6 billion devices running either Linux or Unix, and 10 and more expected has become billions. And it's hard to go any place and not find one. You see a street light? It's probably running Linux. You see lights in your house, if they're smart lights, they're running Linux. And they're everywhere, okay? Just today, yes, I managed to crack into the operating system in the electrical plugins that do USB on my wall. I've got in my lab, I've got a couple plugins I put in that have USB ports in them so I can charge things. And they claim to be smart power-saving ports that they will shut down when they're not being used, and they power up and they charge things when they are being used. And I went, I wonder how those things worked. And I have an extra one. I, of course, took it apart, poked into it, and yes, I found a chip, and yes, I can now log into my plugins. It didn't take very long before I could figure out how to crack into those too. And each one of these things, okay, has a computer in it. Computers are everywhere, and they're eating the world. And by and large, most of them are running Unix. So in 1969, they wrote this thing to play games. There's a bunch of features of Unix that have come to fruition in all sorts of operating systems. In 1971 was their first edition. The first edition was used by 3 typists in the Bell Labs patent department, and that was their first deployment of their Linux system. They only had 1 computer, so they had to share it with the people developing the operating system, which, as Thompson described, was kind of dicey because you could crash it and ruin their work for hours. In 1973, the 4th edition of Unix, and this was the first one that was written in a programming language called C. I learned C when I was here in college, and Python is written in C. In fact, if you start poking around at open source projects, and you add up to all the different programming languages that have been used, you'll find that a huge proportion of these, I'm not talking a small, like 64% of all the source code out there in the world, when you start adding it up, is in C. Because it's been around a long time and a lot of people have written big C programs. Python isn't the only thing. The Oracle database system is written in C. The Postgres database system is written in C. And there are newer versions that are extensions to C called C++ that you go on to the next class here at UW, you're probably going to be learning C++. But yeah, I am an old C programmer. I still program things in C to this day. And because there are all these small devices, and C was written for building small devices and things that didn't have much memory, you're seeing a resurgence in C programming. And I think that's going to continue because there's going to be way more IoT devices in the future, and lots of them are not very big. Lots of them are very small computers. And C is really good at working at that. It's a hard language to learn, a hard language to use well. One of the reasons we're not teaching it is, boy, it is unforgiving. It just does not check all sorts of things, and it can send you for hours hunting the most esoteric things. And in Python, at least when you use a constant like 1, the value is still 1. In C, you can change 1 to be 2. And that will make your programs do the most entertaining, in a negative sense, entertaining things that you can possibly imagine. But it is trivial to do stuff like that. So, yep, that was the first version in C. The C language was developed for Unix, for writing the operating system in. And somewhere around this point, they'll eventually get to System 5. System 5 was about 10,000 lines of C code for the entire operating system. So it wasn't a huge piece of code, not by today's standards. But, yeah, it was one of the amazing concepts that came out of Unix, is that you could write an operating system in a high-level language like C. Before this, everything had been written for operating systems in assembly language, like IBM's OS 360 and 370 were giant assembly language programs with hundreds of millions of lines of assembly code. This is the machine code that the machine actually runs. So the fact that it was written in C suddenly gave them portability. And that would turn out to be a huge thing, is that they could take the operating system and they could move it to new hardware. They got new hardware and they started adding a file system. And they experimented with a bunch of different ways of doing it, but they invented some things that were useful in that file system. One of them was AT&T did a study and found out that upper lowercase words, names, were more readable, so they included upper lowercase file names. If you go back to about this point in time, you've got the Apple IIe, and it was uppercase only. I worked on a research computer here at the University of Wyoming in the mid-'80s that was uppercase, and if you stood on your ear and twisted in just the right way, you could convince it to do lowercase, but only with great effort. And by and large, it was all uppercase. There were uppercase-only programming languages, like basically Fortran 66 didn't support lowercase letters. Fortran 77 eventually did, but it was very rare. Most programs were written in uppercase only. So, yes, 73. By 1980, there was 7th edition, was out of Unix. They had, I believe, 10,000 people using it, an installed base, and they were looking at getting to, 20 or 30,000. And in 1980, this new computer company called Microsoft started offering a Unix system called Xenix. I was actually exposed a little bit to Xenix a couple years after this, and I was thrilled because you went from these computers that were really, really tiny to one running Xenix, and this was a big deal. I mean, it was a multi-user time-sharing system. Not just one person could use the computer, and it wasn't running on one of these DEC PDP operating systems that was totally proprietary. And it included things like you could actually run stuff and find out what the commands were that it did. It wasn't a bunch of books that you had to spend $60 a volume and read the books. They'd actually done an amazing thing. On Xenix, they had the manuals online. I mean, can you imagine that, where you could actually read them on the computer itself? It was amazing to me, at least. So, about 1984, Berkeley had a research project, and they released Berkeley BSD 4.2. I mentioned that the Macintoshes are derived from, I think, Berkeley 4.3 is the origin where they split off, but 4.2 ran on DEC's VAX systems. And in 1986, I was here at the university working, and a professor here had a research project, and we bought one of these VAX systems, and we ran it 4 days a week with VMS on it, the native operating system that it was designed for, and 3 days a week we ran it for doing research with BSD 4.2. And for various reasons, I was one of the few people on campus that had ever worked with a Unix system. And I was an undergraduate student, but I got to be the system administrator. I did the backups. I switched operating systems on it. And basically, there was 1 day a week for 6 hours when I booted everyone off the system, and I got to play with the entire computer by myself. I was developing device drivers for it, for a project they had that was funded, and I had dedicated hardware in this system. Now, this research computer supported operating systems, research, students doing stuff, professors doing stuff on one single VAX 11785. And to give you some idea of the compute power, if you go out to Walmart and you buy one of these cards that sings Happy Birthday, you know, we're back to the birthday thing, and it goes Happy Birthday to you, and does a horrible job of singing and making the music of Happy Birthday. Those cards that you buy for, I think, $3 have about 1 million instructions per second, and they run on a battery in the card. And the VAX 11785, that was this multi-user system doing all these things, has right at 1 million instructions per second and half as much memory as the card. And so that's kind of the change that you see between then and now. Now, all of these things, BSD 4.2 had taken the original file system and it had added the ability to do longer file names, but it still worked about the same as the file system from the late 70s on Unix. And it was a hierarchical file system. It was upper lowercase, and they had introduced this wonderful capability of having programs and being able to just send the output from a program into a file. And you could actually write your own programs. You could add new programs to the system, and they would have this capability. And it was fairly easy to do. You could sit down and see, and you could write a program, and it would work this way. You could also do something else with programs that was truly magical, that didn't really exist on other systems. And that was the ability to take the output from one program and make it the input to another program. And you could combine all these things into shell scripts. And shell scripts meant little pieces of code that you wrote that were interpreted by the same thing that you typed in your command interpreter, and build these into scripts, and you could build bigger things. It had all these tools that came with the system. Good heavens, that was a nice thing. And you went on other computers and you had to buy the tools. On a Unix system, it came with, yes, a C compiler and a Fortran compiler. And it came with tools for formatting documents and searching and all this plethora of tools. So there was this huge environment that it came with that allowed you to do all sorts of interesting things with it. It was an exciting time. And there was this amazing file system that was pretty darn reliable. It worked. which compared to some other systems I was working on the time, was pretty good. There was a computer here at the University of Wyoming that we had that had a student class on it that tended to overheat, and consequently we had set the computer up next to the window. And if it was a warm day outside, we ran a fan in the window blowing on the computer. And if it was a cold day, you had to watch it carefully to make certain you didn't get snow in the window on the computer, because otherwise the computer would overheat and fail. And we were doing an entire operating system class on that computer. So, a computer that actually worked in a machine room and ran a Unix system, this was a big deal. So, having actually built stuff like that, I went on to build my first product, which was for a proprietary system. But that first product I got out the door was for NCR cash register systems and things like grocery stores. It was a scanner system. And it was a compiler that they used to optimize a bunch of stuff. It actually ended up turning into my master's research. But I managed to build the original version on, yes, another Unix system. I bought a PC, and there was an open source Unix system that you could run on it, and I got it installed and got it working, and I built that tool and sold my first piece of software on that tool. Now, I'd been doing some other consulting work, but I sold that piece of software, and it was a big deal. I got $10,000 for building this optimization and selling it. And the key to that whole project was that I could build it on Unix, and I could take the same code that I'd built on Unix and recompile it on an NCR cash register system. They had a C compiler, and it would work on both systems. So portability was the key to my development process. I hadn't thought too much about it, but I went off and I did some consulting work and a lot of other jobs, and most of them were on Unix systems. I tended to, Macintoshes were out there in 1984. They had the first Macintosh. And it was running Apple's own proprietary system, and it was really expensive, like $4,000. Today that would be like $10,000 for a desktop PC. And I wanted one so bad, but I couldn't afford it. So I stuck with building things on cheaper hardware running Unix and clones of Unix. And by the 1990s, I had spent, a decade or more building software on Unix systems. And one of those things early on that I found was that there was this database Oracle, and it ran faster on Unix systems than it did on other operating systems, by about 10%. And I took that single fact that I knew and built a consulting company around that to actually port people from other systems onto Unix and run Oracle on Unix, and do training and consulting with this optimization. So Unix became an integral part of my operation and what I was doing. And I went and got a contracting job with IBM in New York for 2.5 years. And they found out that I knew about Unix, and consequently, they gave me the Unix systems while other people got other things on this project. And I had, at IBM, a Sun Solaris box. It was one of their competitors. I had Digital Equipment Corporation, PDP 11 somethings running Unix, and I had access to a VAX there because we were building software and it had to run on all these things. And we networked them together, including IBM AIX boxes, and we were testing software on all these different things, including, interestingly enough, a system with a kanji keyboard. Do you know how hard it is to type in English commands with a kanji keyboard? I do, because I did it all the time. I had all these sticky notes on my wall to go, okay, I need to type in this command, therefore I'm going to do this special key, that, and there we go. So it was an integral part of what I was doing. The 1990s, I sold that company, went and took a couple years off, and when I came back, I went back to doing consulting work, but mostly Oracle installs, and all of them were on Unix. So I was just used to using Unix. By this point, Unix had become the mainstay of all sorts of server operations. The world of servers, for big businesses was Unix and Digital Equipment Corporation, VAXs, and their proprietary OS VMS. I had worked on VMS, but I did not like it as much as Unix, and I certainly didn't know it nearly as well. And there were other operating systems, primarily when things having to do with banks, where they were using IBM mainframes and things like Teradata. And I didn't really pay too much attention to it. I was just going along with Unix, and one day there was this open source thing, it was about 1992, called Linux. And Linux was the thing that I added to my repertoire. Pretty soon you could run Oracle on Linux, and it was being used all over. And I have programs from 1994 that, yes, I compiled and ran on Linux then, and I took the binaries and ported them up until maybe a year ago, just copying the binary from system to system, still running the exact same things that I built back then, and I eventually had to recompile them, but basically, yeah, they still ran today, which is an amazing feat of stability in software, that you can take it from version to version of Linux, and it continued to work after decades. So there was a lot of good things about it. The file system was consistent, and it had all of these capabilities of pipes and files and how it worked and how it forked processes. And the web grew up on top of, by and large, running servers on top of Linux. And to give you some idea of how important a stable system is that has the ability to run stuff effectively and not crash, the London Stock Exchange was originally developed on top of Windows. And they ported to Linux. It cost them $100 million to do that port, because Windows has the tendency to produce errors that want to pop up a box. And when you have a server and there is no monitor or user attached to it, that pop-up box is kind of a fatal mistake. And consequently, they ported. And a lot of other people have done the same sort of thing. They've ported to a Unix system. Well, by 1999, that was the year my kids were born, Unix was 30 years old. And pretty much it had spanned every kind of hardware, from things in orbit and satellites to mainframe computers to, the smallest computers we build. And all of them could run some form of Unix. And this meant that you had a single platform that allowed you to port software easily from system to system, to develop it on small computers and run it on big computers. And that capability of separating out the small from the big and being able to do development across an entire range was hugely valuable, and is to this day hugely valuable. And we take for granted some of the things that it brought in, like hierarchical file systems, and building an operating system in a high-level language, the C programming language, text formatting, like and other things that it made the foundation for. In a lot of ways, the ability to format text was predicated upon text formatting things. So tools like HTML, hypertext markup language, were derived from the existing text formatters that were built for Unix systems. So it produced a core set of competencies in a lot of things. But throughout the late 90s and early 2000s, the thing that it shined at was being able to run basically large database systems and act as a client-server system for building applications. And most businesses, that's what they were running. So it persisted and grew, and today it is ubiquitous. So when you see me developing on a Macintosh, I do it by and large because it runs a Unix operating system. And with ubiquitous, we see it today in everything. from cars to SpaceX launch systems to probes that Japan used it in the probes that went out and sampled stuff off of asteroids, to airplanes running it, to light bulbs and furnaces and cars, and everything is running it. All sorts of devices. And underneath the cover, all over, is this portable operating system that was developed for being able to run a game. All right, with that, I'll call it a day. I'll bid you adieu.